Welcome to Episode 6 of the Power Podcast, presented by Power Magazine and PowerMag.com.
The Power Podcast is the latest offering from the longest-running power industry publication in the world. Established in 1882, the Power brand is dedicated to providing its global audience with news and information important to the power generation industry. Now here's the host of the Power Podcast, Executive Editor Aaron Larson.
In this episode of the Power Podcast, I'm joined by Paul Browning, CEO of Mitsubishi Hitachi Power Systems America. I spoke to Paul on December 5th in Las Vegas, Nevada, where he gave the keynote address during a power industry conference. He touches on several subjects during the interview, including MHPS's recent announcement that the company's M501JAC gas turbine, with a combined cycle output of 575 megawatts, reached 64% efficiency and 99.5% reliability. You gave the keynote today during the event. I'd like to have you just give a quick recap of what you talked about.
Well, my theme of the presentation was that there's a change in power happening in our industry. And I talked about a lot of different types of change in power that we're seeing. And I started out by saying that, a year ago, we actually created a website, www.changeinpower.com, because we saw some, really incredible change happening and a lot of it affecting us and our customers. And we wanted to, have an online presence sort of talking about our view on what's happening. So, I started out talking about the changes that we're seeing in developed energy markets, developed power markets around the world, and talked about how everybody's, I think, very familiar that we've seen a dramatic drop in the price of renewables, PV solar and onshore wind in particular, and showed some data that said over the last decade, PV solar is down 20% per year on average, and onshore wind, the levelized cost of electricity is down 12% per year on average. I said what I think a lot of people aren't quite as well informed on is that natural gas combined cycle is actually down 12% per year over the same decade on average. And
I think that's true. I don't think many people do realize that.
So it's the same as onshore wind and of the same sort of order of magnitude as PV solar, and started from a much lower point. So and what's caused that? And I talked about, well, first of all, the new drilling technologies have reduced the cost of natural gas by 70% over the last decade. So that's certainly a big part of it. But also the capital cost of our equipment has come down by about 30% on a dollar per kW basis. So our turbines are getting a lot bigger, and the bigger turbines with all those megawatts in the denominator on a dollar per kW basis, we're able to sell them at a lower cost. And also all those megawatts go into the denominator for the whole plant. So everything on a dollar per kW basis gets cheaper. And then also, as you're probably aware, fuel efficiency, 10 years ago, an F-class fuel efficiency might have been 58% combined cycle. Today, we're talking about 64%, 65%. So, the fuel we're getting is a lot cheaper. We're burning a lot less of it, and the cost of the machine that converts fuel into electricity is 30% less. And you add that all together, and we've taken, an average of 12% per year for the last decade out of the levelized cost of electricity for a combined cycle power plant. So the impact of all of that is that we're a big change in power is we're retiring the 40-year-old coal-fired power fleet that the developed world has, and we're replacing it with a combination of gas and renewables. And that combination of gas and renewables together is actually dispatchable. It costs about $41 per megawatt hour on a 50% gas, 50% renewables. And the carbon intensity of that combination is 85% lower than that retired coal-fired power plant. So then I go on and I showed an example of the GRDA project, which did exactly that. They retired a coal-fired power plant. They bought 400 megawatts of wind PPAs in Oklahoma, a great wind resource. And they also bought a 500 megawatt combined cycle power plant from us, which just so happened to be our first J power plant in the United States. We just went commercial with that a couple months ago. I was at the groundbreaking ceremony, and we announced it's the most fuel efficient 60 hertz power plant anywhere in the world at 62% combined cycle efficiency. So gave the example of GRDA, and then we talked about how there's lots of that happening around the United States, and we sponsored Carnegie Mellon University to do a study of what's happened to the carbon intensity of the U.S. power grid. And the short story is we're down 24% versus 2005 when it peaked. 24% lower carbon intensity today, and 97% of the reason for that is that gas and renewables have been displacing coal-fired power generation. That's what the Carnegie Mellon team found. So, that was one of the change in powers. Then I talked about in developing markets, there's a lot of the same dynamics. However, two things that are really important and different. One is that LNG is much more important in the developing markets, particularly in Asia, where they don't have their own sources of natural gas. And LNG prices have also come down dramatically. They were $18 a million BTUs just a few years ago in Asia. Today, they're $6 to $8. So that same, dramatic drop in fuel prices happened, and they have, the more fuel efficient and lower capital cost combined cycle power plants. And so they're getting a lot of those same benefits on the gas side and also on the renewable side. And so we're also starting this, and by the way, they've all signed up for the Paris Climate Change Agreement. So these clean energies are getting a new priority, and we're seeing gas and renewables, in this case, because there's so much growth in the non-OECD countries, it's just the new capacity that's being put on is this. And then the other big change is that they have brand new coal-fired power generation, which isn't going to be retired anytime soon. And for that, we talked about, we just had our Petronova project, which won Coal-Fired Power Plant of the Year this year, MHI carbon capture technology in Houston that's capturing 90% of the CO2 emissions from an existing coal-fired power plant, piping it to a nearby oil field, using it for enhanced oil recovery. And so we talked about how that's something that's very important in the developing world where they have all these new coal-fired power plants that we need to do something about. So I then talked about another change in power, which is the switch from F-class to advanced class gas turbines. And, the traditional leaders in the F-class are not the same leaders in the advanced class. As a matter of fact, we were sort of a number 3 in the F-class technology. We actually have the largest installed base by far of the advanced class, greater than our next 2 competitors combined. And so we're really the leaders in this advanced class technology. And so we talked about how that's another change in power, right? There's amongst the OEMs, there's a resorting
shifting
of capability, with us sort of emerging as a leader in this, with everybody in the world moving towards these advanced class gas turbines. I talked about a few other things, but the last big thing I talked about is that we announced today that we have broken ground. This isn't some future thing we're going to do. We actually have broken ground this year on a 65% efficient combined cycle power plant that is also going to be capable of autonomous operation. So it's going to have the built-in artificial intelligence to be able to operate autonomously, independent of humans, and make its own dispatch decisions. It'll be connected to the local autonomous weather report. It'll be able to communicate with a nearby renewables project. It'll be able to communicate with off-takers of that electricity. It'll be able to help them anticipate when they're going to have downtime on the equipment that's using the electricity. A whole new kind of power plant that's much more intelligent than what we're used to thinking about for our power plants. And the combined cycle efficiency is, breaking ground on something that's going to be in commercial operation in 2020, puts us well ahead of anything that any competitors announced.
That's fantastic news.
It was a mouthful.
Yeah. No, I mean, it's all great information. And I would point out, too, Power Magazine announced that Petronova was our plant of the year back in August. And the GRDA facility was actually one of our top plants in September for the gas-fired category. So those were definitely on our radar, and we were covering that quite extensively.
Yeah.
So now when you talk about the autonomous power, that's something that we also cover quite a bit. We're really into the connected plant and, monitoring and diagnostics and all of that sort of stuff. And I was talking earlier with somebody else about MHPS, and you've been in that for a long time, doing that sort of, monitoring.
Sure.
So what have you seen over the years?
Well, so 17 years ago, we started remote monitoring and diagnostics. And in the early days, there was a human being watching all that data come in and trying to identify anomalies, which would allow us to intervene before the customer had unplanned downtime. Over the time, we developed algorithms which were able to monitor that data stream independent of a human being. And these were, the first sort of analytic algorithms that were able to detect, again, sort of data anomalies. As time has progressed, the job that the machine is doing versus the job that the human is doing, the split has been moving more and more towards the analytical engine that's getting smarter and smarter, seeing more and more data. We're now using machine learning algorithms that you don't have to program them on what the right answers are. They're starting to learn themselves. What the right answers are. And they're getting more smarter, not just about, hey, here's a problem. They're getting a lot smarter about what should we do about it, right? So that's what's been happening over time. Where we're at today is we're working with partners like IBM Watson, and we have a new program called the Golden Start. This is the coolest thing. So our equipment is very, very start reliant. But our engineers ask themselves, what would we need to do to have, basically perfect golden start reliance? And we talked to the folks at IBM Watson, and they brought in their machine learning, the guy who won Jeopardy, or the machine that won Jeopardy. And
okay.
They are analyzed a whole bunch of data, historical data we had, and they now have the ability to predict with very high accuracy what's the probability that the next time we push the start button that it's going to successfully start. So before we push the button, we have a very good estimate of what's the probability that it's going to start. And what we're not able to do now is anticipate problems and intervene before we ever have a failed start. And so the probability of a failed start has just gone down dramatically. So that, to me, that's a really cool example of how machine learning is taking something that we think of as sort of a mechanical aspect of our product and turning it into something where intelligence is really, machine intelligence is really marrying with the mechanical integrity of our product to raise it to a whole new level, right? So what's coming next is this autonomous behavior, where you've got to. I think about this all the time. Sometimes I use GPS now, even when I know where I'm going, and the reason is the GPS knows stuff I don't know. It knows there's traffic. It's aware of traffic.
Exactly.
I'm not aware of traffic. So if I'm on my way somewhere, even if I know where I'm going, I'll let the GPS give me some advice, because sometimes, especially on the I-4 in Orlando, you got to know that. Well, with an autonomous power plant is going to have that same kind of, it knows stuff that a human operator doesn't know, right? It's going to be connected to all these other intelligent entities. And, we talked about this idea that everything's going to be electric, everything's going to be intelligent, and everything's going to be connected. And as we move more and more into that world, the machines talking to each other are going to be sharing information and making better decisions than an uninformed human operator would. Now,
or even an informed human operator could possibly
a less
do.
informed human. Yeah. So now our vision isn't that we take the human completely out of this, but it's that we have more and more autonomous capabilities that are augmenting what a human operator could do, and just helping make better and better decisions as time goes on.
Yeah. No, I think that's great, and I mean we see it not only in the power industry, throughout the world. Autonomous vehicles, autonomous advertising, and everything is being done by computers and machines, and smarter than we are and faster than we are. And
you think about a future. Today we have automated grid control, which I would say is sort of a reactive way for our power plant to automatically respond to when the grid needs it to ramp up and down. You think about a future where that same power plant is communicating with your autonomous vehicle that's battery powered. It knows the charge in your battery. It knows what it's being asked to do by the ISO, and it knows it's got a little bit of extra capacity that it could use for an industrial customer, or for your car, or for some other purpose. it's a machine that's thinking beyond and knows more than anybody today knows, and therefore is able to optimize the network and create value for our customers that otherwise wouldn't be there.
Right. Now, another thing that I know you guys do a lot of is testing and putting machines through all of the, full operation before you ever send them out into the field. So
yeah.
I heard you were building a new facility that's going to be even more high-tech and more involved in that.
The announcement I made today that we broke ground on a facility that's going to be 65% efficient and fully autonomous, the customer for that is MHPS. Mm-hmm. That is our next facility where we're going to be demonstrating the 65% efficient technology and the autonomous capabilities. Because our whole philosophy and what sets us apart from every other OEM is we buy serial number one ourselves, and we have a long-term demonstration of the reliability of a new technology before we'll ship it to a customer. And so that's just the way we do business. Sometimes it means that our competitors can get to market a little bit before us with some new capability, but our long learning over a long period of time is they're going to have more problems with that approach. We're going to have fewer problems, a more predictable outcome for our customers, and we're willing to let them take a couple of orders with a high risk, lower probability process. And we're going to continue to do things our way. And we have a lot of customers that are very loyal to us because they know they've had that history with us in the past, and we tend to be a pretty sticky OEM. Once a customer starts doing business with us, they like to stay with us because of they learn that we really are different in terms of the risk we put on a customer's shoulders when we're bringing new technology to the market.
Okay, this is going to go kind of off topic, but I know Siemens, for instance, has announced that they're combining their 3 power divisions and laying off or reducing their staff by 6,900 people. GE has gone through a restructuring. They've sold off a couple of businesses. How is the market affecting MHPS?
Yeah, I've had a couple people ask me that question, and I have to tell you, we're not as negative as our 2 competitors are on the future. And by the way, I have to tell you, my responsibility is North and South America. Mm-hmm. So, my comments are directed towards the markets I'm responsible for. We have a lot of activity out there right now. And by the way, a lot of it's fallen our way in the last couple of months. I don't know if that's related to some of the announcements that our competitors have made recently. It's too early to say that, but, we have noticed that, we're batting above our previous batting average lately. And so, we're pretty optimistic about the future. I would say, are we looking for ways to reduce our cost structure and be more efficient as we see our competitors doing the same thing? Yes. But I would say it's more, to make sure that we're maintaining a competitive cost position than it is because we see some fundamental reset in the market. Historically, in the F-class market, we were the number 3 player. And that means as this advanced class market becomes more and more predominant, we have an opportunity to pick up market share. And being number 3 and picking up market share in a soft market, you can still grow. Mm-hmm. And so we're pretty optimistic about the future. We just added to our portfolio by purchasing Pratt & Whitney Power Systems during the past year. We're in the process of integrating that business. So now we have an aeroderivative product line. And while our competitors are really downsizing, particularly in the United States, when GE did their Alstom acquisition, they moved their headquarters for GE Gas Power and GE Power Services to Switzerland. They signed an agreement with the French government that they wouldn't reduce employment. In fact, that they'd increase employment in France. So as they look at resizing their business for what they believe is the current market, a lot of their downsizing has to happen in North America. We're actually growing in North America, and we're, in 1999, we had 5 employees in North America. Today we have over 2,000. And, we see a lot of opportunity here, and we're going to continue to invest.
Is there anything else that you can think of that maybe I haven't asked or that you'd like to talk about?
Yeah, so we've had some really good news. I told you we've had some things falling our way. So our J-class product, which is our most advanced, most fuel-efficient gas turbine product, we now have 74 units that are either in operation, on order, or that we've been technically selected by our customers for. And that technically selected number has actually more than doubled just in the last 2 months.
Wow.
So we have 8 units in Asia, very 5 gigawatt opportunity that just landed. We have I announced at in my keynote that we have a customer, GEL in Peru. They have a project called HUMAI, JAC project that we've been selected for. We have 2 more customers in the United States who have asked not to be identified right now, who just in the last couple of weeks selected us for a 2-on-1 JAC and for a 1-on-1 JAC project. So we've had quite a few orders that are selections that have rolled our way recently, and they become orders when those customers get to financial close. But at this point, we're the exclusive turbine OEM with them. So that feels really good.
I'm sure.
The product introduction has been very, very successful, and we're really looking forward to growing more in the future.
Oh, great. Well, thank you so much for taking the time to talk to me, and I really appreciate it, and I hope you have a great show.
Okay. Thanks, Aaron.
Yep. And with that, the 6th episode of the Power Podcast has come to an end. I hope listeners found my conversation with Paul Browning, CEO of Mitsubishi Hitachi Power Systems America, interesting. If you'd like to learn more about the advances in gas turbines, Power Magazine will be publishing a feature story on the topic written by Associate Editor Daryl Proctor in the January 2018 issue. I'm Aaron Larson, Executive Editor of Power. Watch for the next Power Podcast coming soon. Thanks for listening.